Hey everyone, so let's make this a quick video. I just wanted to show you guys really quick how to do the sum of the forces in the y direction, the sum of the forces in the x direction, and if we have a slant vector as well. So let's start with the y-axis. So so we have this force in the y-axis, and let's call this F1. We have another force, we have another force, like that. This one, let's say it's going in the direction like that. This one's going down. Okay. And then we have forces going in the x direction. Let's say this one's going to, this one's going that way. That one's going that way. And we have a force, vector force going that direction. So let's keep in mind that this right here is our x and y axis. Okay, and I'm assigning that if it goes in this direction, it's going to be positive. If it goes in this direction, it's going to be positive as well. So this one is going to be F2, F3. This one I'm going to have it as force 4, force 5, force 6, and we could just have this guy be F7. Okay. So one of the things that I keep telling you guys is that if you have a force that is slanted, like F7, all you have to do is break it into its components. So you know you're gonna have an X component because it's going this direction, and then you're gonna have a Y component because it's going vertically. So again, that's your X and this is your Y. Okay? And let's say we're talking about this theta angle right there. So if you have this F7 right there, just immediately do sine of theta. Sine of theta, we know that it's going to be opposite or hypotenuse, so it's going to be y over f7. Multiply both sides by f7. So we're going to get f7 sine of theta is equal to the y. So this y component is going to be for this guy's over here. And then we can also have cosine of theta, which is equal to adjacent or hypotenuse. Adjacent to this angle is this x, so x over f7, multiply both sides by f7, okay? And this comes out with that. So f7 cosine of theta is equal to x. Again, this being the x component. Okay, so if I go back to this portion over here, what I would do is that I would sum up all of the forces in the y direction, and I need to set them equal to 0, and then I'm going to do something for the x-axis. So I have, whoops, that's too much. It's, that's fine. So I'm going to have the sum of all the forces in the x direction equal to 0. For this guy, for the sum of the force in the y direction, I have this one, F3. But don't forget that you also have this one. So the way that this will look like, it will be F1 plus F2 plus F3. Oh, my bad. Since F1 is going down, that actually has to be negative. And F3 is going down, so that actually has to be negative as well. Okay? So that's minus F3. In this case, this slanted force going up, so that's going to be positive. Okay, so it's going to be plus f7 sine theta, and it's equal to 0. Now I'll do the sum of the forces in the x direction, and I'm assigning it to go in this direction, positive, negative, positive. So it's going to be f4 minus f5 plus f6, and now I have to get the x component of this vector, which is this one right there. So it's going to be plus, because it's going in the positive direction, f7 times cosine theta, and that is equal to 0. Okay, at this point we don't know what the values of these guys are, so we cannot do anything. This was just a quick setup for you guys to be able to see if you guys have y components, x components, and the slanted forces. This is pretty much the setups that you guys would end up having. Okay, next video we'll go over an example on how to set those guys up. Alright, I hope this helped you guys out. So we'll see you in the next video.